Ever wonder how you build an AI that can handle something as critical as a medical emergency? Well, today we're going to pull back the curtain and go inside a truly sophisticated AI medical assistant. And here's the twist. It's not one single superbrain, but an entire coordinated team of AI specialists.
All right, so here's our game plan. First, we'll meet the virtual team. Then, we're going to put a single AI agent under the microscope to see how it actually thinks. After that, we'll follow a patient's urgent query through the entire system, from start to finish. We'll also uncover a really clever engineering trick that makes all of this practical. And finally, we'll zoom out and talk about what this means for the future of AI.
So the big idea, the real game changer here, is to stop thinking about one giant general-purpose AI. Instead, this system builds a team of highly specialized AIs. Each one has a very specific job, just like a real medical team you'd find in a hospital.
And this visual just nails it, right? A request comes in from a user, and this central coordinator, the classifier, acts like a hospital's charge nurse. It looks at the problem and immediately routes it to the right specialist for the job. It's all about getting the right expert on the case, instantly.
Okay, to really see how this works, we're going to follow a patient query. And not just any query. We're talking high stakes here. Chest pain, dizziness, nausea. These aren't simple symptoms. They demand immediate and very, very careful attention.
So how does one of these agents actually think? Let's zoom in on the very first agent to see that patient's query, the Triage Agent. You can think of this one as the first responder on the scene.
This is our frontline specialist. Its entire purpose in this system is to take in that raw human language, the symptoms, and make a fast initial assessment of what could be going on.
Now this is super cool. We're literally looking at the AI's instruction manual. Its prompt. It's being told exactly what its job is. You are a clinical triage assistant. And crucially, how it needs to format its answer. It has to return something called JSON, which is just a perfectly structured way of organizing data, so other computers and AIs can read it without any confusion. And boom, here's the magic. The agent takes that messy, conversational human input, chest pain, dizziness, nausea, and turns it into this. Perfectly structured data that the rest of the system can act on in a split second. Urgency, high. No ambiguity, just a clear signal.
Okay, so that's one agent, but what happens next? Let's follow that high urgency tag as it travels through the entire virtual clinic, getting passed from one specialist to the next.
Now look at this workflow. The query gets passed along like a baton in a relay race. It doesn't just go to one place. And notice something really important? The safety guardian shows up not once, but twice. This whole process isn't just about speed. It's about building in safety at every single step.
So, right out of the gate, after triage makes its call, bam, the safety guardian jumps in. Think of it like an automatic, mandatory second opinion. Before a specialist even lays eyes on the case, this agent scans for any critical red flags, acting as a crucial line of defense.
And look at the result. The system has already identified a potentially life-threatening pattern and has flagged the case for immediate escalation. And this happens in seconds. In a real emergency, that's a critical time saver.
Okay, now the coordinator sends the case to the cardiology specialist for a deep dive. But, these big AI models can sometimes ramble a bit or be unclear, so it doesn't stop there. The specialist's raw output is immediately sent to another agent, the refiner, whose only job is to clean up the language, make it safer and easier for a human doctor to verify. And here it is again. The safety guardian runs a second time. This is so critical. It inspects the final polished recommendation after the refiner is done, just to make absolutely sure it's safe before it gets stored or shown to anybody. This double check is a core feature for building trust in the system.
So we have this amazing, multi-step, safety-first process. But how on earth do you build and test something this complex without going broke? Calling all these powerful AIs costs money. This is where the engineering gets really, really smart.
Well, the design is just brilliant. It basically has two modes, a testing mode and a go-live mode. When developers are just building and testing, they use these fast, free mock agents that run right on their laptop. But when it's ready for the real world, the exact same code can flip a switch and start calling the powerful, state-of-the-art AI models in the cloud.
And this is how they do it. You don't have to be a coder to get this. This little piece of code is the magic switch. It basically just asks, hey, do we have the keys to the supercomputer today?
If the answer is yes, it uses the powerful cloud AI. If not, no problem. It just falls back to the simple, free version. For any developer watching, this is just chef's kiss, a beautiful pattern for building real-world AI safely and affordably.
Okay, so let's zoom out. What's the big picture here? Why should we care about this multi-agent design beyond just one really cool medical application?
Really, what we're looking at is a blueprint for the next wave of AI systems. The big lesson is that a team of specialists almost always beats a single genius, especially when you have a great team captain, that orchestrator agent, calling the plays. And those layered safety checks, they're totally non-negotiable in any field where the stakes are high. You can imagine this exact pattern being used for finance, law, you name it.
And this right here is where it's all heading. This might look complicated, but the idea is actually pretty simple. It's called an Agentic RAG workflow. Now, RAG just means the AI can look things up, kind of like using Google, so it's not just guessing. This diagram shows a whole system of agents that can reason, use tools, and remember past interactions. This is how you solve messy, complex, real-world problems.
Which leads us with one massive final thought. We've just seen how this virtual team approach can bring order, safety, and speed to a complex medical situation. So the real question is, what other impossible-seeming problem are they going to solve for us next?